Section number 14 is entitled Polar Coordinates and Graphs. First I'm going to give a polar coordinate and then going to ask how we convert it to a rectangular point. Now, first maybe I should give you their translations. The x value is always r times the cosine of theta. And the y value is always r times the sine of theta. And while we're at it, y over x is always the tangent of theta, called identities. So if you're given 4 comma pi over 2, this is a polar coordinate. How do I know? Because I'm telling you that. There's no other way to know. The first value is r, and the second value is theta. So I want to write this in terms of x comma y. Well, I know x is, well, r is 4 cosine of the theta is pi over 2. Now, it turns out that the cosine, well, there's pi, the cosine of pi over 2 is 0. So we get 4 times 0, which of course is 0. So we now have the x value. The y value is going to be plus or minus 4. Because it's y is 4 times the sine of pi over 2. If the cosine is 0, at that same angle, the sine will be plus or minus 1. So it's 4 times, and we look at their sine graph. Here's pi, there's pi over 2. The value is 1 at pi over 2. Because when you look straight up and down, where do I hit this graph? Where did that line hit that graph? Right here. It hit right here. And when you look across, you see good old 1. 4 times 1 is 4. So it's 0, 4. Yes, it's a coincidence that 4 was part of both points. Didn't need to be that way. Okay, let's try another one. X is just 4 times the cosine of the angle. Y is just r times this sine of the angle. X is r times the cosine of the angle, and y is r times sine of an angle. And if you ever calculate it, it's very straightforward. What if you're given 0, negative pi? That means r is 0, and the angle is pi. I mean, we're going to get 0, 0. I hope that's kind of obvious, because when you multiply two things, and one of them is 0, because r, like r, then the whole product will be 0. This is 0 times the cosine of pi. Pi is right in the middle. That value right down there is negative 1. 0 times negative 1 is 0. 0 times the sine of pi. Well, if cosine is plus or minus 1, sine will be 0. And let's just verify that. Pi is right there, and the graph is right there. The y value is 0 right there. Whenever r is 0, regardless of the angle, the point is going to be 0. The coordinate, the rectangular coordinate will be 0, 0. Go to angle pi or negative pi and go out 0. Okay, let's reverse the game. What if I give you a rectangular point? Now, before I do this, let me write the rules down. Excuse me. Y is r sine theta, and y over x is tangent theta. So I give you a coordinate 1, 1. This is rectangular. I'm giving you rectangular, and I'm telling you or asking you to write it down in polar. I need to know two things. I need to know r, and I need to know theta. Well, let's find r. 1, 1. Here it is. R is this length. In fact, R is always, or R squared is always x squared plus y squared. So R will be the square root of that. And if I complete a right triangle, this is 1 and this is 1. You square x, you square y, you get r squared. Call that r. That is, r is the square root of x squared, which is 1. Y is also 1. X squared plus y squared, which is the square root of 2. So now I have r. I need to get theta. I'm going to use this rule right here. I know that y over x, which is 1, is the tangent of theta. The tangent of pi over 4 is 1. Theta is pi over 4. Now, the reason I'm using pi over 4 and not 5 pi over 4 is because our point 1, 1 is in quadrant 1. That is, this angle is between 0 and pi over 4. Excuse me, 0 and pi over 2. It's between 0 and 90. Now, if they would have given me the point -1, -1, they would have given me this point, then I would have used that angle. Up to here is pi, and this is still pi over 4. So the whole angle would have been 5 pi over 4. Okay, so, but they didn't give me that. They gave me a rectangular point in quadrant 1, which is very important to know that it was in quadrant 1. Okay, and there it is. It's square root of 2 comma pi over 4. Try another one like this. Give you a rectangular point and ask you to convert it to polar. How about 3, -1? We can find r easily. X squared plus y squared square root. That's r. 3 squared plus -1 squared, 10. It's the square root of 10. Okay? So now I know r. It's the square root of 10. What is the angle? Well, the tangent of the angle is y over x. The tangent of the angle is y over x. And we can try to draw this. Now, 3 -1, I mean, here's 3, and here's -1. So it's right there. We know that this is 3, and this is -1, and we just learned that's the square root of 10. Problem is we don't recognize this as any special triangle. I mean, the answer is going to be is theta is going to be the tan inverse of negative 1/3. Will be the tan inverse of negative 1/3. Use your calculator, figure out what that is. Now, tan inverse is, if I'm not mistaken, and I might be, it may not be defined, let's suppose it's defined in quadrant 4, tan inverse. But what if we were in quadrant 2? So what you might do is say, you know what, let me just find the angle in quadrant 1. And the answer would be the tan inverse of 1/3. The tan inverse of 1/3. And that would be an angle between 0 and 90 degrees. Let's just say, for argument's sake, it was 20 degrees. That is, this angle up in the top right is 20 degrees. Well, then that angle down there will be negative 20 degrees. So the answer would be the arctan of the third, but negative. Now, what if we were in quadrant number 2? This angle here would be, say, my 20 degrees. Well, then what angle is this? Well, it's the whole angle, pi. Take away the part you don't want, namely the arctan of 1/3. This angle here would be pi. Take away the arctan of 1/3. That way, you never have to worry about, is arctan defined in quadrant 2? It's certainly defined in quadrant 1. The tan inverse of 1/3, or as I just said, the arctan of 1/3, that's an angle in quadrant 1. Don't worry about it. Center it where you want. If you want it in quadrant 2, do theta minus. What if you wanted it in quadrant number 3? Well, then you have to go 180 degrees plus the arctan of 1/3. It would be pi plus the arctan of 1/3. Now, why would you do this? Well, you'd want to do this. Again, I forget where arctan is defined. But let's suppose it's defined in quadrant 1 and 2. And you found out that the arctan of negative 1/3 is 75 degrees. You know that's 75 degrees. But there's a big problem. Since our point 3, -1, since the point they gave us, let me erase a lot of this. Since the point they gave us was in quadrant number 3, quadrant 4, like our picture shows in the right corner now, it's going to be a pain in the neck to convert the 75 degrees into something in quadrant 4. I mean, first you're going to have to say, oh, obviously that's a silly number. Say it's 105 degrees. First you're going to have to say that this is 75 degrees, and then our answer here is negative 75 degrees. And that was a bit easier, what I just did, because we use degrees. If it's in radians, it's going to be a mess. I think it's better to always find, if the angle is the arctan of a negative number, forget about it. Find the arctan of that positive number. And then add pi, take away pi, put a negative sign in front like we did. Nonetheless, there's the answer. You want to find the tan inverse of the third, fine. Don't forget to put a negative sign in front of it. Okay, think about what I'm saying. I promise you, in the end, the way I'm telling you to do it is the cleanest, easiest way. it weren't, I wouldn't understand it. Let's try one more. Suppose you have 4, 6. So we need to find r and theta. Well, r is a bit easy. It's x squared plus y squared. Remember, that's x, that's y. X squared plus y squared is square root. 16 plus 36 is 52. 52, I know from a deck of cards, is 4 times 13. So it's the square root of 4 times the square root of 13. And personally, that's how I write down the square root of 4. So we have r. It's 2 square root of 13. I'm going to be a pain. I'm going to make that negative the square root of 6. So now we know that y over x y over x is, which is 4 over negative 6, which is negative 2/3. That's the tangent of theta. Now for negative 6, x is 4, y is negative 6. In fact, let us even have, I'm going to reverse it. It's 4, negative 4, positive 6. It's negative 4, positive 6, which still turns out to be negative 2/3. Okay. So negative 4, positive 6. It's right here. We are in quadrant number 2. So my job is to figure out what's that angle. What is that angle? Well, I'm just going to find out the tan. I'm going to solve this equation. Notice I didn't put the negative. So theta will be the arctangent of 2/3. Now, the arctangent of 2/3, 4, 6, that's this angle. But you know what? This angle here is the same as that angle, that reference angle here. It's the same as this angle. But I don't want to know this angle. I want to know this angle here. So what I do is I make a slight mistake. I go too far. I go out to pi. And then I say, oops, I went too far. Let me take away what I didn't mean to, which happens to be the tan inverse of 2/3. And what do you know? I get the angle that I want. I get the angle that I want. So there's the angle. So it's comma. I'm going to run out of room, but it's pi take away the tan inverse of 2/3. That's the answer. Let me put it down here. 2 square root of 13, comma, pi minus the tangent inverse of 2/3. That is the polar coordinate of negative 4, 6. And you want to find the arctan of 2/3 and take away that from pi? Fine, you can do that. Arctangents are not defined in all 4 quadrants. So even if I knew, and I won't even bother to look it up, even if I remembered, actually, let me think of it real quickly. It must be defined in quadrant 4 and 1. So if you have an angle in 2 or 3, using their arctans won't help you. Okay, now we want to convert the given rectangular equation to polar form. Suppose you have that x squared plus y squared is equal to 9. Now remember, X is R cosine theta. Y is R sine theta. X squared plus Y squared is R squared. And Y over X is tangent of theta. Well, that's R squared. That's R squared. R squared is 9. There it is. There it is. Done. Suppose you have X squared plus Y squared minus 2ax is equal to 0. Well, that's R squared minus 2a. Now, x is R cosine of theta equals 0. You can leave it like that. You can say R squared equals 2a R cosine theta Now, it's not reasonable to assume that x squared plus y squared is 0. That would mean x and y are 0. If x and y are not both 0, that means r is not 0. You can divide both sides by r. Okay, there's a nice answer. If you had a nice equation like x is equal to a, well, x is r cosine theta. Here it is. Now, x equals a, if you think about it, that's a vertical line right here at a. Because all those points on that dotted line have one thing in common. The x value is a. So, I guess this is a vertical line. That's a vertical line. How about this line? 4x plus 5y is equal to 7. That's an equation of a line. 4 is 4, x is r cosine theta, plus 5, y is r sine theta, 7. Straight line. Slope is not 0 or undefined this time. Here's one problem. Here's another problem. If y was a constant, y is 11. That's a horizontal line that crosses y equals 11. Well, y is r sine theta. And it always equals 11. 11 is 11. Y is r sine theta, but a number is a number. How about one more? Let's try that again. Suppose you're given x squared plus y squared minus x squared minus x squared minus y squared, let's square this, equals 4. Well, x squared plus y squared, that's r squared, which I have to square. Minus, let's just say minus 4. That way there's a reason not to distribute the 4 with a minus sign. Well, x squared. Square x. You get r squared cosine squared theta minus y squared. R squared sine squared theta. That would be your answer. R squared times sine squared theta. And this is still equal to 4. Now we should clean this up like r squared squared is r to the 4th. In the second term, you can factor out an r squared. Cosine squared theta minus sine squared theta is 4. Most students, I bet, would leave it like this. But remember that sine squared plus cosine squared is 1. So if you bring this over to the other side, you learn that sine squared is 1 minus cosine squared. So that sine squared, I'm going to put 1 minus cosine squared. You have r to the 4th minus 4r squared times cosine squared theta minus all of 1 minus cosine squared theta. This is 4. Okay, but if you have cosine squared theta and you take away negative cosine squared theta, you get 2 cosine squared thetas. So it's r to the 4th minus 4r squared times 2 cosine squared theta minus 1. This is equal to 4. There's a nice answer. Okay, now of course we reversed the game. Just now I gave you our rectangular equation, and I asked you to convert it to a polar equation. Now I'm going to give you a polar equation and ask you to convert it back. Suppose I tell you that r is equal to 4 sine theta. Now, the easiest way to do this is to multiply both sides by r. So r squared is 4r sine theta. And r squared is x squared plus y squared equals 4 r sine theta is y. Done. I wrote an equation that just has x and y. That's when I stopped. Well, you might, not in this case, but you might want to clean it up. But once you have x's and y's, you're done with polar. But you should clean it up. Make it look nice. Yeah, r squared is equal to sine of 2 theta. Okay, what you have to do is be slick. R squared is equal to, now sine 2 theta is 2 sine theta cosine theta. Now, the 2's no big deal. Let's factor that out. But if you had an r multiplied by the sine theta and another r multiplied by the cosine of theta, that would be real friendly. Because r sine theta is y and times r cosine theta is x. I just multiplied the right side by r times r. That is r squared. Well, multiply the left side by r squared. But the left side is r squared. That is, square it. Square it. It's a coincidence. It's a coincidence. Multiply the right side by r squared, I square the left side. Why was I allowed to square it? Even if I did say, okay, I'll multiply the left side by r squared. Let's do that. So the left side becomes r to the 4th. And for the record, if you square r squared, you get r to the 4th. But now, r to the 4th is r squared squared. And this is still 2yx. The reason I want to write it as r squared squared is because I know how to write r squared. And then I'll square it. And that equals 2yx. And there it is. Okay, r to the 4th is r squared, which I know how to write squared. And if they ask me to write r cubed, well, I would think of r cubed as, now I want somehow to get a square. Divide by 2, multiply by 2. That is, this is r squared to the 3/2. That's r cubed, and it has an r squared in it. R squared is x squared plus y squared. That's r squared to the 3/2. That's r cubed. Okay, so if you need to convert r cubed, you can do what I just did there. Somehow you want to get r squared to a power. Now converting that one really made life easier. I mean, what if you had this? R squared is 8 sine theta. R squared. Excuse me, say r cubed. R cubed is 8, no, r squared, but that's fine. R squared. So what you do is you multiply both sides by r. The left side is r squared. Well, you want to get r squared, but you also want to get rid of the 2 and bring in this 3. So you raise it to the 3/2 power. Well, r squared is x squared plus y squared to the 3/2 power, and this is equal to 8 times r sine theta, which is y. There it is. Now, possibly what a textbook might do is they would square both sides. So when you square the left side, it just becomes x squared plus y squared cubed. And when you square the right side, you get 64y squared. That might be a nice way of writing the answer. But the line above was fine. Let's try one more. So, these conversions, x squared plus y squared equal r squared, and y over x equal 10 theta, and x is r sine theta, and y is r cosine theta. Can't do these problems if you don't know this. You have to know that like you know your name. Suppose you had this problem. Well, I'd multiply everything by r. Now you can square the left side and you'll get r squared. But when you square the left side, you're going to get sine thetas and sine square thetas. But if you multiply by r, you'll get r sine theta. That's the only one that's a bit of a pain in the neck. Well, r squared is x squared plus y squared. So r would be the square root of r squared. Be the square root of x squared plus y squared minus 2, and that's y, minus 2y. Final answers, you would want to try to get rid of their square root signs. So let's bring the 2y to the other side of the equal sign. So x squared plus y squared plus 2y. This is the square root of x squared plus y squared. Square both sides. And the left side, don't really square it, just to note that you're going to square it. And do in fact square the right side, which is x squared plus y squared. Nice clean way of writing the answer. Depending upon your teacher, the line above might be acceptable. The teacher says time and time again, final answers cannot have square roots. Final answers cannot have square roots. Well then, don't leave it. Don't leave this line. Don't leave this line as your final answer. For one simple reason. It has a square root sign. Teacher said final answers should not have square roots. Just add 2 on both sides. Okay, those are the things I don't know. I don't know if your teacher, I don't know how far your teacher wants you to go with an answer. Not a mind reader. Okay, next set of problems. This time we want to sketch the graph of the polar equation. Suppose you have that r is equal to 5. That is, for any angle, for any theta, r is 5. It's called the constant. R is always 5. Okay, the polar paper, here is r is 1, there is r is 2, here is r is 3, 4, 5. That last circle I drew, that's your answer. And you can make up a table, theta r. And theta can be 0, pi over 4, pi over 2, 3 pi over 4, pi, etc. And you want to fill out, you're going to fill in the r's. Well, when theta is 0, what does r equal? 5. When theta is pi over 4, what does r equal? 5. In fact, r is always 5. So when the angle, so let's draw some of these angles. When it's 0, you go out 5. When the angle is pi over 4, you go out 5. When the angle is pi over 2, you go out 5. When it's 3 pi over 4, you go out to 5. When the angle is 4 pi over 4, you go out 5. 5 pi over 4, you go along this line a length of 5. When the angle is 5, you go out 5 units. When the angle is this angle was 3 pi over 2, excuse me. When it is 7 pi over 4, the angle, you go out 5. That is, along this line, you don't 1, 2, 3, 4, 5. You go out 5. And when x is 2 pi, which is the same as 0, you go out along this line. How far do you go? 1, 2, 3, 4, 5. You go here. Each of these lines have numbers. Whatever angle you're talking about, it has its own lines, its own numbers. 1, 2, 3, 4, 5. Since all the points on the red, if you were to sketch it out, you get a circle. Circle of radius 5. If you think about it, r, oops, maybe I'm wrong. But I shouldn't be. Yeah, x squared plus y squared is equal to 5. Square both sides when we come over here. Then you get x squared plus y squared is equal to r squared, which is 25. That's the equation of a circle where that's r squared. If r squared is 25, then r, the radius, is 5. Okay, so that problem is done. R equals any constant is going to be a circle. Whose radius is the absolute value of that constant. If r equals -5, that would give you the same graph as r equals 5. Think about why that's true. Now 47, this one's interesting. R is equal to theta. Okay? So let's see what's going on. We have R, we have theta. In fact, I don't know why I'm drawing it differently than I always used to draw it. R and theta. R and theta. So if theta is 0 or pi or 2 pi or negative pi or negative 2 pi, R is equal to theta. So theta is 0, R is 0. Theta is pi, R is pi. 2 pi, 2 pi. Whatever theta is, do you know what R is? As the angle increases, let's talk about first the angle being positive. As the angle increases, R increases. That is, when R is 0, you're right here. Pi over 4, you're right here, pi over 4. At pi over 2, that's more. 4590 or 3 pi over 4 is here. 4 pi over here is here. 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4. It's like a spiral. It gets bigger and bigger and bigger. It goes around and around and around. And I don't know what happened here. It starts at 0. But now, what if the angle's negative? What if the angle's negative? When the angle is negative pi. Negative pi, start at the origin. Here's the origin and go negative pi. That brings you all the way around to right here. That's negative pi. And of course, it contains 0, 0. Okay, negative pi. So I'm at the correct angle. That is, I'm along this line. How far along this line? Negative pi. That means go the opposite direction. Go here. I mean, if you think about it, what you're going to get are these points if you go reverse. Okay? You're just going to get those points. It's going to be the mirror image. Just think I didn't go big enough. But I'm hoping you get the point. It'll just be something like this. It'll be something like that. It's a mirror image. It's a mirror image across this line. The right half and the left half should look the same. That is, what's in black and what's in red should be identical. If you fold along the line. And there it is. A lot of students might say, oh, this one's very easy. It just looks like that. You're half right. You have to go the other way as well. You have to go the other way as well. But it's a spiral. Actually, it's two spirals. One going clockwise, one going counterclockwise. You have to look at all possibilities. You have to think, no, what if the angles are negative? Is that going to affect this? What if you wanted to draw r is equal to sine theta? Theta and r. 0 pi over 4s, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi's over 4, 6 pi over 4, 7 pi over 4, and then 2 pi, right at the root. The sine of 0, well, let us draw a sine graph. I know the sine of those angles. Pi over 2, pi, 3 pi over 2, and 2 pi, and 0. So let me do that. Sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is the negative 1. And the sine of 2 pi is back to 0. What about those other points? The pi over 4, the 3 pi over 4, the 5 pi over 4. That's pi over 4, pi over 3 pi over 4, 5 pi over 4, 7 pi over 4. Well, pi over 4, the sine of that is square root of 2 over 2. It's 3, so that's square root of 2 over 2 right there. Square root of 2 over 2. The sine of 3 pi over 4 looks exactly the same. But the next two, they're almost the same, except now they're negative. Negative square root of 2 over 2. Negative the square root of 2 over 2. Or if you insist, you can use your calculator. Problem is your calculator is not going to give you the square root of 2 over 2. So now we go and we graph this. The biggest that r is 1. So let's just make believe that that's 1. No x, sorry. Okay, so when the angle is 0, theta is 0. That means you don't, if the angle was 0, but r was 1, that would bring me here. If r is a half, it would have brought me there. That is, I'm going along the line r is equal to 0. Now, if it said 0, negative 2, well, you don't go in the positive direction, you go in the negative direction. Whatever the angle is, if this is if this hair up here is pi over 4, well, you could extend it, and here's positive 1, positive 2, positive 3, 4, 5, negative 1, negative 2, negative 3. But now, if we were talking about 5 pi over 4, which is this angle down here, then down here would be the positives. Positive 1, positive 2, positive 3, positive 4, negative 1, negative 2, negative 3. It is each of these angles come with their own number line. And once you start seeing that, maybe this becomes easier. Okay. So 0, 0, we plotted pi over 4, square root of 2 over 2. Square root of 2 over 2 is less than 1. Because I know that square root of 4 over 2 is 1. Square root of 2 over 2, since the bottoms are the same, and the top is smaller, the square root of 2 is smaller than the square root of 4, then square root of 2 over 2 is 1. So at pi over 4, I go out square root of 2 over 2. At pi over 2, I go out to 1. So far, I've gone like that. And at 3 pi over 4, which is this line right here, I go out square root of 2 over 2. And then at pi, which is this line right here, I go to 0. I go back to 0. It brings me right there. And then this just repeats. At 5 pi over 4, which is right here, I go negative the square root of 2 over 2. That is, I end up right there. I end up over here. Because along this line, this is the positive numbers. This is the positive numbers along 5 pi over 4. If I want negative, I have to go the other direction. Okay, at 3 pi over 2, which is this line right here, I go negative 1. That brings me right there. That is, I'm continuing this way. In fact, I'm going around and around. Now, you may have to say, but wait a minute, what if the angles were negative? What if the angles were negative? Now, please remember that the sign of a negative angle is the sign of the angle with a minus sign in front of it. That is, you just get negative what you got if you took the sign of the angle. So, if these angles suddenly become negative, if these angles suddenly became negative, the sign of those angles, which I have those, the signs of the positive angles, I have the sign of those angles right over here. I have the sign of those angles. But I'm supposed to put a minus sign in front of them. Remember, if you put a negative sign in front of a negative number, it becomes positive. And if you sketch this out, you're going to get a similar answer. At negative pi over 4, which is this angle right here, at negative pi over 4, I go negative the square root of 2. That is, I go the opposite direction. I go to right there. Okay, and negative 3 pi over 2. And negative 3 pi over 2, I go out 1. Well, negative 3 pi over 2 is right there. It's this line. And I go 1, which brings me right there. In fact, I'm getting back the same exact circle. Exactly the same circle I'm getting back. And there are reasons I want to erase this. Now what if I take this same equation, r equals sine theta, and I add 2 to it? What if I add 2 to it? That is, instead of r just equaling sine theta, it's sine theta plus 2. I think you realize that I should add 2 to my r values. R, I just went 2 more. 0 plus 2 is 2. Plus 2 is 2 plus square root of 2 over 2. 1 plus 2 is 3. You add 2. You get 2 plus square root of 2 over 2. 0 plus 2 is 2. You add 2. You get 2 minus square root of 2 over 2. You add 2, you get 1. You add 2, you get 2 minus square root of 2 over 2. Now, for every angle, okay, before we got that. Well, what should we get now? I mean, we can just plot this all over again. The biggest R value I get is 3. So make believe that's 1. That's 2. That is, this is your graph paper. Your graph paper may not have those dashed lines I drew, but they have the circles. Okay. So when theta is 0, I go out 2. Puts me right here. When theta is pi over 4, I go out more than 2. I go out 2 plus a little less than 1. That is, I'm between 2 and 3. I'm out here. And then at pi over 2, I'm way at 3. Okay. And at 3 pi over 4, I'm less than 3. I'm 2 plus that square root of 2 over 2 stuff. And then at pi, I'm exactly at 2. So far, it's that. Okay, and that brought me out to pi. At 5 pi over 2, 5 pi over 4, a little bit less than 2. 2 minus square root of 2 over 2. That puts me a little bit more than 1. And then at 3 pi over 2, I'm exactly at 1. Now, 1 looks, this circle looks a little bit off-centered. Let me try to draw it a little bit better. Okay. So now, at 3 pi over 2, I'm at 1. And then at 7 pi over 4, I'm more than 1. And then at 2 pi, I'm going to be 0. Excuse me, I'm going to be 2. The sign of 2 pi is 0. 2 plus is 0. So, pretty you got the circle there. Now, that'd be hard to, it would be hard to look at the first what to do. We did this line mechanics. Again, at the next angles and see what would happen. See if you put negative 45, negative pi over 4, negative 2 pi over 4, negative 3 pi over 4. Is that going to affect things? The answer is no, but you should think about it. Next and last problem we'll do is to show that this is a circle. To show that r is equal to 2 times h cosine theta plus k sine theta, that's a circle. Now whenever I see cosine thetas and sine thetas alone, that is no r sine theta, r cosine theta, I think of multiplying by r. I multiply the left side by r. I multiply the right side by r. Multiply this by r. And multiply this by r. And basically, I multiplied the left side by r and the right side by r. And then I distributed the r. And that gave me my second line with an r here. Next squared plus y squared is equal to 2 times hx plus ky. 2hx plus 2ky. X squared plus y squared. I'm going to bring over the 2hx as negative 2hx. I'm going to bring over the 2ky as negative 2ky. So since I brought everything on the right side to the left side, the right side is now 0. X squared minus 2hx plus y squared minus 2ky. This is equal to 0. But now, pre-calc. I want to complete the square. I want to complete the square. I take half of the value in front of x. I take half of it. That is, I divide it by 2. I get negative h. And I square that. H squared. That's what I add on. Add it on to the left side. The right side is no longer 0. Take half of that number. Take half of the number in front of the y. Get negative k. Square it. Get k squared. If I add on k squared to that second bracket, then that second bracket is a perfect square. The first bracket is a perfect square. It's x followed by half of 2h, which was negative h, all squared, plus y followed by half of negative 2k, which is negative k. And this is equal to h squared plus k squared. H squared plus k squared, that's my radius squared. Remember, x minus h squared plus y minus k squared is equal to r squared. That's the center of a circle, centered at h, comma, k. Where the radius would be, if r squared is h squared plus k squared, then the radius r is the square root of that. Please, this is not h plus k. But nonetheless, I just showed that that top equation is the equation of the circle. Okay, that completes the section entitled Polar Equations, or Polar Coordinates and Polar Graphs. Good luck with it.